Hi friends, welcome to our channel Education Hub. Education Hubs gives you always the important lectures. Now today at first we will start our discussion about the 8085 microprocessor. 8085 microprocessor is a 8-bit microprocessor attached with the central processing unit. It has single shift IC or integrated circuit, especially the functional components of CPU be using the arithmetic logic unit ALU control unit, and not only that, the other registers. Now 8085 microprocessor, I already told it is the 8-bit microprocessor. It includes the chip on the most of the logic circuitry to perform the computing task and communicating with the peripherals. Now, one thing I have to tell you here in this lecture, on this video, we will try to cover up all the 8085 pin configuration, their address modes, instructions, etc. Now, if you want to learn it, then don't skip it, go through thoroughly. And another thing, that if you don't have to go through it thoroughly, you have to go through it. If you're able to go through it totally, then it will be beneficial for you for getting ideas about other microprocessors, that's like 8086 or 80 any other series of Intel microprocessor or microcontroller. It is 8085, what I am telling, 8085 is a microprocessor prepared by Intel series. Intel x86 series gives you the Intel x85 series gives you this type of microprocessor. Here all this programming, all this architecture of the microprocessor is developed based on the computers, hardware computers like, but not the total hardware computers type. So that's why there are some specifications is there. Before doing just starting all the discussion, I have to tell you the Intel 8085 is the easiest most part of the microprocessor, which you can able to understand totally, then it will be helpful for you to get the idea of others. And here at first I have to tell you the total features. What is 8085 and what they need? First of all, we will start that discussion. That is, first one, the features. I already, several times already I told you, this is 8-bit microprocessor. So if it is 8 bits, then obviously these 8-bit microprocessors have data buses 8-bit, and just double of that need the address bus. That means 16 bits address bus. That means 16 bits address bus and 8-bit data bus. So the memory size should be 216, obviously, that is 64 kilobyte. In this way you try to remember, then it will be better, as because many of you have the idea that our microprocessor is very hard. No, it is very important and very much you have to like, otherwise you cannot understand computer. So please go through it. The features is showing in your screen also. Already I discussed, this is 8-bit microprocessor and 8 data lines and 16 address lines is there. So the memory size is 64 kilobyte. Now the clock frequency. Clock frequency is 3 megahertz. And obviously for any type of IC we need some power supply, that is positive 5 volts. And it is also IC, so developed by any MOS category. It is NMOS category, not at all PMOS. Many of the architectures will show you NMOS devices implemented with 6200 transistor. And 74 instruction sets is there. It will be 5 addressing mode. At the end of the lecture, I will show you that this 5 addressing mode, the immediate, implicit, or direct, indirect, all this. Now, the I will discuss that, and another thing, that is the last one, that is it will gives you the interrupt. I know that we all know that within an interrupt period, the all the processes should be done, and if the interrupt period is over, that the job is not over, then the timeout option will comes to your side. So this is the basic interrupt, and this Intel 8085 consisting 5 hardware interrupt and 8 software interrupt. Now, what is interrupt? I have to tell you. Suppose it is in sleeping mode. Now, if I give some instructions, it give you some hamper of the sleeping mode. That is the interrupt begins, and interrupt obviously within a timing request will comes. Within that time period, they will try to do the operation. If it is done, then okay. If not, all the modes, that means ready mode or any other modes, you have to cover up there. If not, then you have to stop it and restart it. This way this operations just goes on. Now one thing, this interrupt period is very much necessary, because within this interrupt, when you work in any kids or any other where, there also you need this interrupt cycle or interrupt period. Now this interrupt period is very important for us. Now before starting this all, we have to show you the pin configurations. There are total 8 bits microprocessor, I already told it. So total 40 pins will be there. Now this 40 pins will be categorized in 6 groups. Now see this. This is the total pins, 40 pins, and the 6 groups is given. This is address buses, data buses, control and status line. Address bus, data bus, by the name you can able to get. We will discuss here also in later. That data buses show you all the data records visible. Address buses total the address parts. Control and status lines gives you the total controlling parts, controlling status. These are externally generated. Some externally generated instructions will comes from there, and the serial interface, one by one all the interfaces will be there, and the power supply and clock will be generated. Now these are the pin configuration of our 8085, Intel 8085. Now here one thing I have to tell you, that Intel 8085 microprocessor will show you the detail, and the pin by the pin diagram. Already I show you the diagram. I will show that diagram you have to memorize, and this memorized diagram also gives you the total detail. Now within this clock cycle, so all the clock cycles, serial interface, these are tell you the total work what will be done in an interrupt period, and the serial interface will gives you the details about all other operations. Now after this discussion, the pin configuration, what I already told you, I will get the address bus details. Right now we will discuss about the address buses. See here, this is the address bus which gives you the knowledge about the total addresses, one where of each bits. So therefore total 16 bits here that is given. See here, 16 wheres the binary number carried the alert of memory. Open the design box, then the data, that is binary, can be put in or taken out. It is given A15 to A8. AD7 to AD0, these all the total, A15 to A8, 8, and A7 to AD7 to AD0, 8. The total 16. The 16 lines is designed for the 16 wares to get the over. Now here all this will comes total 16 bits mean 216 different numbers or 32000 different numbers of binary. This consists the box of each unique address. The size of the address bus determined by the size of the memory which can be used here. And the memory also, data buses gives you the same way 8 wares. Now the control lines or control buses. Here we will get RD, WR, IOM. This all means read, write, input, output, memory. By the name you can able to get the detail of that. And the status line, that is status means S1 and S0. It gives you the microprocessor 8085 has two status pin S1, S0, which used to indicate the status of the microprocessor, whether it is enable or disable, whether it is 0 or 1, or the operation which performed by the microprocessor. Now this control bus or control lines has various lines which have specific functions and for coordinating or controlling the total microprocessor work. Read, not write line, write, not read, and input output. Now here we have to know the spatial signals also. Those are ALE. ALE, that is the address latch signal. It is used for enabling or disabling external latches. The external latches IC's numbers is also given 743738212, and the external latch IC is used for demultiplexing of AD7 to AD0 lines. That is, it is used for separate the address and data forms AD7 to AD0 line. Here, if the ALE equal to input output, then the external latch will be enable or disable respectively. Now here one thing you have to learn, if the today's microprocessor you will get, there different types you will get. Now the signal group is given here. Please follow the screen because by the verbal lecture we can't able to explain it, where the reset 7.5, reset 6.5, reset 5.5, INTA, ready, hold, HLDA, INTA, read, write, memory, signal 0, signal 1, ALE, and the address buses is separated here. Now here the power supply also showing in the signal groups. Here the address buses, the higher order address bus and the lower order address bus will be separated. Please follow the screen. Here I already show you the all details. Actually total 40 pins is there, we know, because now this 40 pins, what way the signaling will be maintained, that is given in this pictorial view. Here the pin diagram totally, you can pause the video and you can draw it because it is very important. Because if you work in any kit or any other where also, there also you need the pin diagram. Now the pin diagram of 8085, I'm not telling you all the details because only the you have to memorize this. In what way you can memorize? See this x, y, 1, 2, x1, x2, this 2 the input is given, 3 output already in linear side C we already followed. So there you have idea. Now SOD, SID 45, that is serial input, serial output. If 45 is this, then 6 should be trap. Then 7, 8, this is 2 resets, 7.5, 6.5, and there we will get the reset of 5.5. That way you have to remember the INTR should be 10, 11 INTA. So the address buses will comes from 87 to 80. This all. Now another lesson, there also the data buses, address bus, where the hold, where the HDLCA, HLDA, these all, or where the clock we will get, these you have to memorize. So that way already I told you the type that you have to follow, and you have to remember the total pin diagram. Now from there you will get the demultiplexing of the address modes. See here, I am taking only the higher order addressing modes, that is AD0, AD0 to AD7, these and ALE I am taking. Now this will comes and generate the decoded version, which gives you the A0 to A7 and D0 to D7. See here, follow the screen. These are the diagrams which help you to understand totally the 8085. And that's why I told you don't skip it. If you skip, if you don't able to get any pictorial view or any explanation, then you can't able to get it. So go through it once. I think you can able to get it. I give you the time to go through. By giving the pausing the video, you can draw, or in between that also you can roughly design. Now this is the total Intel 8085 architecture. This architecture, from this internal architecture you will get the total idea. Now here, this figure, all the accumulator, that means the resistors, all details you can able to get. Now here you know that's the resistor or interrupt IO control or serial IO control. These are the main basic parts, and here from you will get all the detail of the operation. You know, ALU is known as the accumulator, is known as the 8-bit resistor, which is the main part of ALU, and accumulator is that one that take the all mathematical and logical operations. So how the operations is goes on, from this pictorial view you can able to get. There the timing and the control is also given, and the ALU and the decoder of the machine encoding, instructions register, flag flip-flop, temporary register, and all details is also given. So follow the screen. I already, whatever I told, this all are given in this screen, in this picture. So go through it. I think you can able to get it right now. Now one thing I have to tell you, I am giving you enough time for this picture only because this you have to take and memorize. Either by pausing this video or in between this video also you can draw this, or if you want to learn totally from this video then draw it, else take a photo, because when we start the all instruction sets, there also you have to compare along with this video and this picture. So for that purpose it is very important. This is the basic instruction sets and architecture, Intel architecture, total internal Intel architecture of 8085 microprocessor. Now, see this, and here I will discuss the another thing, that what is instruction sets. Instruction sets, by the name you can able to get whatever the instructions will be given by the addressing mode. It will goes to general purpose register, and then the general register indirect will goes to the accumulator, and there the operation goes, and the direct immediate of 8 or 16 bit data. Now see here the program mode, you can able to see here the total architectures part is given, that is the ALU, the timing and control unit, general purpose register, program status word, program control, stack pointer, instruction, register and decoder, interrupt control, serial IO control, address bus, data bus. These all are very important architecture. Before giving the pin diagram, I want to show it to you. Already the pin diagram I show it, but after that I show you this also again, once again, because these points you have to learn, then only you will do that. Total pin diagram. Now we will discuss the pin diagram. Before that, I have to tell you, these names, you by the name you can able to get ALU means arithmetic logical unit, where the operations is going on registers. Then the timing control already I discussed, right, the control bus. Now the general purpose register store the data temporarily. Program status and program counter. Program status will show you what it is, waiting mode or it is reading mode or any other, and the program counter will tell you the all counting operations. Now the stack pointer tell you one by one operations when it will goes on. See here, it will gives you the programming model. This is the thing. First one, A, 8 bits gives you the ALU. B3, B gives you the 8 bits. D, 8 bits. H is also 8 bits. These are the accumulator. And the flag registers are C, E, L. These also 8 bits. If it is that because it is 8 bits register. Now the stack pointer, obviously it will be doubled, because here also you are getting the left side and right side, both are 8, so the total 16. The program counter, which counts the total programming affairs, that also 16. Now the address bus and data buses is giving you in the pictorial view. So I think from this diagram it will be total clear to you the total structure or programming model of 8085. Now when we start our mod programming, I think it will be clear to you. So if you draw it totally in the bigger diagram, that is where the total architecture I show, then you don't need, else you can draw it also. Now the register, all the registers are 8-bit and 16-bit size of different processes. At first I have to tell you about the accumulator. Next, B, C, D, E, H, L. B, C, D, E, H, L, all are general purpose register. They are actually using purposes of taking some data records just for temporary storage purpose. Here this register can also used as 16-bit operations in pairs. They are the default pairs, that is B, C, D, E and others. An accumulator, the operation theater where the all operations will goes on. Now the ALU is that one, accumulator is that one where 8-bit address buses is given. After that we have to know the flag register. The flag register's design is already given. See this register indicates the status of ALU operations. This follow the size. the total S, Z, AC, P and Y. It is given here. The Z is the called 0, CY gives you the carry, S gives us sign, parity, P, and auxiliary carry gives you the AC flags. These are the most commonly used flags, and the 0 carry sign gives you the all the details. These are the microprocessor flags. Now comes to the program counter. Program counter gives you the total 16-bit register deal with the sequence of execution of instructions. Now the stack pointer. Stack pointer is a 16-bit register is used for memory pointer. It points the memory location in read-write memory. It is called stack. Beginning of the stack defined by loading 16-bit address in the stack pointer. And the temporary register WZ, temporary register, you can able to get the name by the name that these registers are only used for 8085 and only are not available for the programmer. These are the memory register. So I think after this much, this all the instruction sets is clear to you. Already we discussed from the accumulator, flags, general registers, then PC point counter, stack pointer, memory registers. These all are, I think these all are clear to you right now. Now the instruction registers or direct decoder you need. These instruction register and decoder are the temporary store of current instructions of the program. We will discuss that right now. Before that, I have to tell you this. I think if after reading this instruction sets, if you go through the once again you back and you go through the total architecture of the 8085, then it will be clear to you very much. Now we have to discuss something regarding the ALU. ALU, that is the 8085 ALUs, performs the 8-bit architecture logical operation. The arithmetic and all the logical operations will goes on. And the timing and control unit gives you the brain of CPU and generate all the timing and control signal to perform all internal and external operation of the CPU. And the instruction decoder and machine cycle encoder unit gives you the unit of decodes the opcode and signal in the interaction register IR. Now the encoder, it is the timing and control unit to perform the execution of instructions. One thing I have to tell you that these all are very very important purpose, and all the instructions already we discussed. So these details if you have, then the instruction registers will gives you the detailed idea about the Intel 8085's architecture. See here the bus architecture or the bus structures is showing. This is the 8085 microprocessor. Here the A0 to A15, the 16 address buses goes. The memory input, output, which comes from the real world, all the instructions, and it will goes through the data buses D0 to D7, and total the control will be goes controlled by the control bus. This is the last line, you can able to get the last row. This is the total bus architecture. In this 8085, this is totally architecture of Intel processor, and any type of processor or as well as controller based on these architectures and this structure. So if you understand it totally, then it will be helpful for you to get knowledge about all others. I think this video will be help you to get little bit idea about microprocessor. Now here the overall structure I declare, I showing you. See, as because several time I ask you to follow the screen, because these pictures I can't able to explain by our verbal communication. There we need the diagrams. See here the MEMR, MEMW, that means read and writing purposes. These and the AD7 to AD0 showing you the latches. These all are the overall structure. In the separate colors also I give you that. Now the microprocessor MPU, microprocessor communication and bus timing, I'm showing in this diagram. Here the ALU, our instruction encoder, decoder, the control logic and the bus registers, all the register along with the stack pointer and program counter goes to internal bus. From the operation memory, the memory location, this instructions goes to the address bus, and from the memory it is comes by data bus, and the control logic connected with the memory also. See, this is the very easier way to understand the total architecture. Whatever I already told you, blah blah blah, that you all get from this basic. There is the all buses timing will get. In our computer architecture lecture, you will get the total bus detail, that is address bus, control bus, etc. Now all the instruction sets already I told. For the programming purpose, what you need, that we will discuss right now. Here broadly the instruction sets can be categorized three: one word, one of code, only one word of code, two word of code, three word of code. Two word opcode, obviously opcode and operand should be there, and three word opcode, operand and operand, that will be. Now the examples is also given here. Now based on that, the functions is data transfer group, arithmetic operations, logical operations and branching operation. You can able to get this, and the machine control instructions is can able to get from here also. So these are the basic instruction sets. For any type of programming, any type of assembly level programming also, or any microprocessor kit, if you want to work, these instructions you have to follow. Please go through the screen once. You will get the knowledge about this. Here one thing I have to tell you, this meaning of this MOV means move. Now ADD means add, JUMP means jumps from here to here, from one register to another register, HLD means hold. These you will be able to get for any mnemonics in our mnemonics lecture of 8085 also there. Therefrom also you can get that lectures. So if you like this, then you can write down these instructions also. In our kit manual also you will get that. So if you like to go through, then you can go through from there also. Some key details and kids important lessons also we will give in our another lecture, which will come very soon. I give you enough time to read it once, because it will be helpful for you. Now after that, this total, I am telling you the address modes of different, that is immediate. I already told you that the address modes I will discuss: immediate address mode, register address mode, direct indirect address mode, and the implicit or implied address mode. Implicit or you can able to get immediate means what the operation immediately goes on, register where you have to store. Direct indirect modes will gives you the direct operation or indirect operations. Now the implicit or implied mode means sometime the operation you have to hold, sometime you have to reset, sometime you have to redo this operation, or it will be making you learn null operation. Then these type of implicit mode or implied mode you need: HLD hold, NOP no, RST reset, RED read. These purposes. So until this much, I think it is clear to you. You can write down those examples also if you need. And we are about our completion of this lesson. Now this video I want to tell you, clarify you all the very important part of 8085 along with architecture, instruction sets, pin diagram, pin configuration, and different address modes. This much was discussed here, and the operations of 8085 kit will be discussed in another, and other microprocessor and microcontroller also will be discussed. Now if you want to get this type of lecture, then don't forget to subscribe our channel. And not only that, after subscribing, don't forget to press the bell icon to get all future notification. Before ending, I have to tell you the timing diagram. Already I discussed, but once again for your visualization, to make you more and more easier, I give it to you. 8085 microprocessor have 7 basic cycles. These basic machine cycles are opcode fetch cycle, memory read cycle, memory write cycle, IO read cycle, IO write cycle, interrupt acknowledge cycle, bus idle cycle. These are the timing diagram. I think you can able to get up to this much. Now we are about end, and if any type of more thing if you want and comment, you can give. We will try our level best to clarify this all. Don't forget to like this video, share it,